Okay, so my name's Greg Nolan. I'm an architect by profession, and it's always a bit hard following one of Christoph's talks because everyone is so inspired to go out and make snake-shaped, complex glulam structures, thinking you can get them on the every street corner. It's difficult because what I'm trying to do, I'll be looking to describe to you now as a new WoodSolutions guide, which in some ways can be compared to a cookbook. In that I've been involved with timber design and education now for quite a long time, and one thing I think is what most of us will admit is that in a lot of the university education, both for architects and engineers, is that we don't get a lot of wood background in it. And so for many of us, we're trying to catch up with a whole range of things and look at presentations like Christoph's with awe about how the hell do we get to understand some of this stuff when we weren't actually taught it at university and we don't actually have a framework in which to set it. So in part, one of the reasons for this guide is to start to establish some of those frameworks and to start to provide some of that background information so that people can improve their design with wood and progress in their practice. Okay, so the authors for the guide is myself and engineer Dan Tingley. Now Dan is an engineer who practices across both Australia and North America. He's a professional of probably 50 years experience in working with wood and timber structures. And we worked cooperatively on the guide in that I helped establish the systems that we'll try and describe through. And Dan and his teams then provided engineering commentary, worked on case studies, etc., as you'll see. So the aim of the guide is then to assist practicing structural engineers and other building design professionals to confidently develop conceptual structural designs for timber-rich buildings and structures. So it has been conceived really as a guide for engineers to get you from a stage where you're not quite sure about the options with wood to having greater confidence that there's certain things you can do. So that's one side. The second side is then for the architects in the room to understand what this shows is possible, to take it along to the engineer and say, see, we can do it, so that you get over that barrier of neither side actually believing what is possible. So the approach we take is we take a whole of process approach in that it explores then the available structural systems, connections and material options, design approaches, performance requirements and material properties, and it includes something but quite important here includes regular options for systems and materials. Now, regular, we decided that regular was probably the best word, is that we didn't want to put in, we're not trying to be encyclopedic. We're not trying to cover everything that could possibly be available or every minor permutation of the thing. It was things we wanted to cover enough things so that most people could get most of the options most of the time. And that's where we drew the boundary. We didn't try and extend it into quite much more complex structures, but things that would cover maybe 90-95% of jobs that most people would come across. We also then included 2 worked examples, because for those in the engineering fraternity, you need to have greater we wanted to build confidence in that people could actually calculate the various components and could see how they were calculated. So the guide's broken up into a range of sections, and the sections then are aligned with the stages of the conceptual design process. So you start off with brief formulation, you work then through to the information search, all the things that you need to understand as you seek to develop a solution. There's then conceptual design stages, and then there's detailed design and documentation are recognised. Now, The guide doesn't want to go into detailed design. It doesn't want to provide you a fire detail. It doesn't want to show you how to design for durability, but it wants to direct you to the other guides that exist that will do that. And so this then becomes a directory so that you know that at this stage you should go off and get that guide and look at that in more detail. So I just want to address then what we handle in each guide. Now, the other key thing is that we've used icons a lot, and I'll show you what that means in a minute. So if we look at the sections, section 1 deals with why would we want to use wood in the first place. So there's a range of environmental and cost and other implications that come when you decide to use wood, and we need to get those out at the beginning. The next is what is our system's options. So if we're looking at a system of assembly, by either structurally or architecturally, or preferably both, what then can we choose from? The next one then is that if we've got these systems, how we join them is going to affect both the cost and the aesthetics of the combinations in the design. So we look at the connection options. We then have to make the thing out of materials. So then we look at the material types that are available. We then look at the construction options, how you're going to put this thing together. We look at then design approaches. So there are certain ways in which things have to be assembled to satisfy particular sets of performance requirements. Now, I'm going to go through each of these sections again in a couple of worked examples in a minute. So this is why I'm rushing through these now. The next thing is that there's actually a lot of stuff about wood that most people don't realise. A key thing is that if you're used to using steel and concrete, then you're used to making man-made materials that generally have a high energy, a relatively limited product range, and they're being designed to satisfy to give you a particular performance level. Now, unfortunately, wood's different. Because with wood, the tree grows what it wants based on its genetics. And we try to harness that genetic output to do different things, which means we've got products that are highly variable. They're highly variable, they're hygroscopic, they're anisotropic. Now, if you come from a steel and concrete background and you don't actually know anything about those things, then there's lots of problems you're going to face. So we had to explain them somewhere, and that's where we explain it. So if you want to know why wood shrinks and why moisture content is important, and because Christoph will have mentioned moisture content through his presentation and how people had to cover things up and how it causes all these problems, well, we cover why that's a case there in that material properties section. I'm not going to deal with that much else today, except to say that it's there. Beyond material basics, there is then material properties. Now, properties is different to basics because in the first one we explain what moisture content is, how shrinkage is related to moisture content, etc. in principle. With material properties, we then go, well, if you've got this species, this is the shrinkage rate you're likely to expect. So if you understand that, make the difference between those two things. We then deal with performance requirements, and there are a couple of specific performance requirements which deal with wood, which are different to things that might apply with other material bases. So they're set out, and we look at two things. One is basically the National Construction Code, which of course we all read and move around with us. And the second one is that there is a whole range of things that are tied up with the fit for purpose requirements in the Australian consumer law, which with wood we've got to make sure we handle some of those things because it's a variable material again, and it might do some things that we don't expect, we wouldn't normally expect if we're using a steel and concrete option. There's then a section on aspects of using AS 1720, and then there's two worked examples. This is the little 3Ds for each of them, and we'll have a look at what's included in each of those towards the end of the presentation. Okay, and then we reference other WoodSolutions guides, and these are two that people will be using quite a lot. One is the timber frame construction for multi-residential buildings, class 2 and 3, and the other one then is the timber service life design guide. And if you're using wood outside, then that should be something that you've got readily available to refer to on almost every occasion. Okay, so designing with a natural resource is different than designing with a man-made one. There's a whole range of reasons for that. Is that the wood is generally processed quite near to where the wood is grown, so it's a regional based thing. Wood production is not that capital intensive compared to something like steel production. And it's highly workable and you get a whole range of different products out of it. So to help balance and understand some of these variabilities, or to, at least for us to describe them regularly, is we use a lot of icons throughout the text. Because we didn't want to try and put all the information in one spot because you just can't explain it all. So generally we're using icons for materials. So obviously these first four are particular materials you might get at a hardware store, and assemblies. So the four on the right, the right, are ones that you could assemble up from some of these other materials. We also then use icons for construction options, how you might fit one thing next to another, how you might run a bracing system, or how you might approach something like prefabrication.